Welcome to this INSUL tutorial about modeling quad constructions. INSUL 10 can predict the sound insulation performance for quad walls and ceilings that include up to 3 distinct air cavities. This is an extension of earlier versions of INSUL, which were able to predict the sound insulation performance for single, double, and triple constructions with up to 2 distinct air cavities. INSUL's quad predictions are expected to be helpful for modeling the sound insulation performance of modular building systems. These systems typically include modular single-cavity cassettes, which are transported to site and installed as an adjacent pair with an intermediate air cavity to form an intertenancy partition with 3 distinct air cavities. The algorithms for INSUL's quad model implement a diffuse field airborne sound transmission method using a combination of longitudinal, bending, and shear wave models for the airborne sound insulation performance of homogeneous isotropic panels. Other panel types, such as orthotropic panels and sandwich panels, are accounted for by amending the classical models across appropriate portions of the assessed frequency range. INSUL's model for predicting sound insulation performance through the structural path of a wall or ceiling, for example via framing elements, has been refined and now takes better account of the mass and stiffness of the frame. The models developed for quad predictions have involved significant backroom development, and rather than being an extrapolation of models from earlier versions of INSUL, they are a re-expression of the prediction methods from the ground up. The principles of the INSUL 10 quad models are also now the foundation for all single, double, and triple system predictions. This means that INSUL 10 predictions are distinct from earlier INSUL versions. It also means that a sound insulation prediction in INSUL 10 will often have a different predicted spectrum when compared with the results of the same model from, say, INSUL 9, even if only by a few decibels in some 1/3 octave bands. The preparation of INSUL 10 has involved extensive validation of the refined models using hundreds of different sound insulation test reports. The validation studies demonstrate that on average, INSUL 10 is as accurate or incrementally better than INSUL 9. Though it should be noted that the relative accuracy of INSUL 10 and earlier INSUL versions can vary from case to case. Preparing a quad model in INSUL is very similar to preparing a double or triple system. Here is some laboratory transmission loss test data for a quad system, sourced from the catalog of STC and IIC ratings for wall and floor ceiling assemblies, published by the Office of Noise Control, California Department of Health Services. The quad system comprises 4 separate linings of 5/8" Type X gypsum board, 2 sets of 2x4 timber studs, and 3.5" infill blanket to 1 air cavity. For this particular dataset, the INSUL prediction is in reasonable agreement with the measured data in the low-frequency region. In the high-frequency region, INSUL predicts sound reduction values that are higher than measured values. One possibility is that it is due to the INSUL model assuming that there is no structural or bridging path across frame 2. That is to say, for the INSUL model shown, the structural path across this frame transmits 0 energy. Depending on the lab configuration, it's possible that there is some small amount of flanking or energy transmission through the structural path. To estimate the effect of such a path, we can change the frame 2 connection type to generic continuous test frame. With this change, the INSUL predicted sound insulation performance at higher frequencies aligns better with the measured data. Even with the change of connection for frame 2, it is apparent that for some 3rd octave bands, the difference between measured and predicted sound reduction values is sizable. This type of variation is a continuation of the validation trend observed across double and triple systems that as the complexity of the construction increases, so does the variability between measured and predicted levels. If you have any questions about this tutorial, please contact your local INSUL distributor.